Hi, hello, welcome to my YouTube channel, Engineering Drawing or Graphics. My name is Munish Kumar, and from my ability to share knowledge. In this channel, I will give you a broad idea of constructing the various engineering drawing concepts with the several types of problems or questions within a step-by-step procedure. In these videos are useful for all engineering disciplines of a first year of BE or b.tech degree, and moreover the channel is emphasizing on tips and tricks for good understanding while depicting or constructing the drawing. I'm not a robot. It's a purely interactive section, and this might be useful for novel engineering students who deals with engineering drawing. In this video, we are going to discuss about the scales and the types and important tips for getting a good marks along with one simple example problem on plane scale. Generally, used scales in engineering drawings are we have reduced scales, engineering scales, and full-size scales. First one, reduced scales. Reduced scales means if the dimensions on the drawing are smaller than the actual dimension of the object, we use the reduced scales. For example, we use this type of scale in topographical or geographical political maps, and our civil engineering point of view, we use in road network or municipal drawings or various construction drawings, and in the mostly we use under mechanical point of view, mechanical components. These are some of the reduced scales represented here. For example, 1:2, 1:50, 1:1000, 1:5000. What does it mean? For example, if we take a 1:50, on the drawing we are showing the 50 units of the actual drawing or object. We are reducing up to 1 unit here. That's why we scale it as a reduced scale. Okay, for example, if we take 1:1000, length of the object 1000 units, and we are reducing into 1 unit. So called as a reduced scale, and here we represent it as a 1:1000. So similarly, actual length of the object here we reduce into 1 unit on the drawing. And next one, we have a engineering scale or enlarging scale. In some cases, very small dimension objects like tiny mechanical parts. For developing detailed sectional views of these type of products, we use engineering scale. We have engineering scales like 50:1, 20:1, 10:1 here. And what does it mean by this 50:1, 20:1, 10:1? Let's understand one example here. We have a 20:1. So actual one is a 1 unit on our object. We are showing to enlarging up to 20 times the what's the actual size is. So says it's called engineering scale or enlarging scale. So 20:1 means we are showing 20 times the actual scale of the object. Similarly, here we have a 50:1. Here is the 1 is the actual length of the object of 1 unit, and we are enlarging them to 50 times or 50 unit. And finally, full size scales, we have represented as 1:1, and here actual length of the object is reflected in the actual drawing shown as 1:1. And this is all about our general understanding of scales. Don't bother about all those important things here. Just for understanding, I explained all those different types of scales. Generally, exam point of view, we use only our reduced scales here. Let's get into our work. Okay, for drawing about different types of scales, for example, we have a plane scale, diagonal scale, or vernier scale. In further slides I am explaining all of them in detail. Important term is representation factor. What does it mean by representation factor? Representation factor is equal to length of the object by actual or maximum length of the object. This is a very important formula while constructing or drawing a one plane scale or diagonal scale or any vernier scale also. So this is a very important formula. If you have a pen and paper, please note on this formula. And from here we will get the length of the scale. Here length of the drawing or length of the scale is the same, and it is determined by the formula RF into, this is just cross multiply this one, RF into actual or maximum length of the required to be determined. So we got a length of the scale by formula equal to RF into actual or maximum length of the required to be determined. It will be called as a maximum length of the object also. Types of scales. We have types of scales, like for example, we have a plane scale here. It's a general representation of the plane scale. Here we have a digits plane scale, and here we can show up to 0.1 digit. That means we can show like a 1.5 to 1.5 or sometimes 22.5. After point we can show up to only one digit here. And further we have a diagonal scales. This is a representation of a general diagonal scale. Here we have a 3 units of representation here. Here kilometers, hectometers and decameters. That means here we can show up to, after point we can show up to 2 digits, 1 and 2. So we can in diagonal scales we can represent in up to 2 digits, like we have a 3.56 kilometers. So for in a diagonal scales the accuracy is up to 2 digits after the point. Okay, and another one is the vernier scale. Here vernier scale is more accuracy than the diagonal scale. This is a general representation of our vernier scale. For example, just for explanation, as a decimeter, centimeters and millimeters, I am explaining all those how we dividing these main parts, how we doing these subdivisions, and this subdivisions, and this is this subdivisions in detailed way. How do we represent here, and how do we take this representation for a good attraction point of view. I will discuss each and everything with the drawing or live interaction. I will explain you all in detail. And at last we have finally comparative scales. In comparative scales, just like we are comparing the two different plane scales here. So I'm not going to the detail in this channel. I'm just discussing about plane scale, diagonal scale and vernier scales. In every scale, 0 should be placed at the end of the first main division. That is, in between the main divisions and subdivisions. Before going to that one, you should know detailing about what is the difference between the main divisions and subdivisions. Here we go. 0 should be placed at the end of the first main division. So here is the main divisions here. The color is a marking shadowing is our main divisions. 1, 2, 3, 4, 5, 6. That is, we have a 6 main divisions over here. Okay, our unit or main divisions and subdivisions. What is subdivisions? We have subdivisions like 1, 2, 3, 4, 5. We have 5 subdivisions. We learned the main divisions and subdivision notation. So let's get it once again. First point, 0 should be placed at the end of the first main division. Okay, from first main division, here is our first main division, here to here our first main division. Okay, here to here our first main division. So 0 is placed or for end of the first main division. Okay, and next point, here we go. Next point, from 0th mark the units should be numbered to the right and its subdivision to the left. So here we have units are numbered to the right, that is 5, 10, 15, 20, 25, and subdivisions here to the left, that is 0, 1, 2, 3, 4, 5. These are our subdivisions, and This blue color mark indicates our main divisions. Okay, this is all about plane scale, and let's go to our diagonal scale. Here, similarly explained before, is in a diagonal scale we have we can show up to accuracy of up to 2 digits, and main divisions are 1 here to here, here to here, here to here, and here to here. Okay, and here to here. Okay, these marks are indicates our main divisions, and subdivisions are a zeroth left part are our subdivisions. Upper part, left of the upper part our scale is a we divide into subdivisions, another subdivisions. Here we indicate the 0 1 2 3 4 5 6 7 8 9 10, and I will explain each and every detail for taking on example problem with our help of using drafter. So don't bother about this one, just for give a glance to general idea about what's a diagonal scale and the plane scale, and then make a difference about the different types of scales here in this video. Okay, next point is names of the units and subdivisions should be started clearly below at the represented hand. So here is a very important thing. In exam point of view, this is a very important thing for getting good marks. If you represent the whole the diagonal scale without any giving attributes like a 0 1 2 3 or units or any representation factor below the diagram, so the examiner won't consider drawing, they definitely lost marks. So please make sure give attention to this point. The names of the units and the subdivisions should be started clearly below the at the represented end. Here the name of the units are here represented as the kilometers and hectometers and decameters. Okay, now subdivision should be started clearly. So here we started clearly 1 0 1 2 3 4 5 6 7 up to the 10. Okay, and represented one end. Here represented one end, and here you go one end, and here is a side is a decameters. And the next important point is the name of the scale or the representation factor should be mentioned below the scale. This is a very important thing you should may remember while drawing your scale. This is a very important thing. You should represent either in middle or in right hand corner. Representation factor should be mentioned below the scale. This has a very important consideration while giving marks for your drawing. In similar fashion, we have a plane scale here represented as a meters over here. Okay, and RF representation factor below the plane scale, and divisions left over subdivisions over here, and main divisions 0 5 10 15 20 25. Okay, it's easy. These two points are very important in exam point of view for getting good marks. Thank you for watching, and don't forget your poster comments, suggestions and doubts in comment box, and definitely will guys, and please do subscribe my videos from habits to share knowledge.